A short answer फर्स्ट आन्सर की 2 मार्कीचला क्वेश्चन असतात. फर्स्ट क्वेश्चन, अ टोरॉइड ऑफ द 4000 टन्स हॅज. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने 2023 मध्ये क्वेश्चन बँक पाठवली होती फिजिक्सच्या विषयाची. त्याची आज आपण आन्सर की बघणार आहोत. आज आपण मॅग्नेटिक फील्ड ड्यू टू इलेक्ट्रिक करंट हा चॅप्टर चालू केलेला आहे. चला तर मग ते क्वेश्चन्स बघूयात. हे शॉर्ट आन्सर फर्स्ट एकूण 10th आहेत. याची आन्सर आहे आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. हे शॉर्ट आन्सर फर्स्ट आन्सर की 2 मार्कीचला क्वेश्चन असतात. फर्स्ट क्वेश्चन, अ टोरॉइड ऑफ द 4000 टन्स हॅज outer radius of 26 centimeter and inner radius of 25 centimeter. If the current in the wire is 10 ampere, calculate the magnetic field of the toroid. Solution given: R1 is equal to 0.25 meter, R2 is equal to 0.26 meter, N is equal to 4000, I is equal to 10 ampere. To find magnetic field of the toroid B, formula B is equal to mu0 into N divided by L into I, where L mean length of toroid is equal to 2 pi into bracket R1 plus R2 divided by 2. Calculation from formula, L is equal to pi into bracket R1 plus R2 is equal to pi into bracket 0.25 plus 0.26 is equal to pi into 0.51 meter. Therefore B is equal to into bracket 4 pi into 10 raised to minus 7 into 4000 into 10 divided by pi into 0.51 is equal to 16 divided by 0.51 into 10 raised to minus 3. Therefore B in is equal to 3.137 into 10 raised to minus 2 t. आन्सर वर्ड प्रॉब्लेम असल्यामुळे आन्सर वर्डमध्ये द मॅग्नेटिक फील्ड ऑफ द toroid इज 3.173 into 10 raised to minus 2 t. Question number second, magnetic field line can be entirely conform within the core of the toroid but not within the straight solenoid. Why? Answer first, the magnetic field around the toroid consists of the concentric circular lines of force around it. Thus, the magnetic field is in toroid of toroid is tangential to each loop. Second, whereas the magnetic field produced by the solenoid is similarly to the magnetic field of the bar magnet. One end of the solenoid coil act as south pole and the other end act as a north pole, with the field lines inside the solenoid remains parallel. Thus the magnetic field B is parallel to the axis of the solenoid. As a result, the magnetic field lines can be entirely confined within the core of a toroid but not within the straight solenoid. Question number third, a solenoid of a length pi meter and 5 centimeter in diameter has the winding on the 1000 turns and carries a current of 5 ampere. Calculate the magnetic field and at it is the center along the radius. Solution given: L is equal to pi into m, diameter is equal to 5 centimeter, N is equal to 1000 turns, I is equal to 5 ampere. We know that mu0 is equal to 4 pi into 10 raised to minus 7 Tm by A. To find magnetic field B, formula I is equal to N is equal to N divided by L. Second, B is equal to mu0 into Ni. Calculation from formula first, N is equal to 1000 divided by pi into turns divided by meter. From formula second, B is equal to 4 pi into 10 raised to minus 7 into 1000 divided by pi into 5 is equal to 20 into 10 raised to minus 7 plus 3 divided by is equal to 2 into 10 raised to minus 3t. The word problem असल्यामुळे फ्रेम केलं आहे आन्सरला वर्डमध्ये. द मॅग्नेटिक फील्ड इज 2 into 10 raised to minus 3t. Question number 4, current of equal magnitude pass through two long parallel wire having the separation of 1.35 centimeter. If the force per unit length on each wire is 4.76 into 10 raised to minus 2 n divided by m, what is the I? Solution: given I1 is equal to I2 is equal to I, F divided by L is equal to 4.76 into 10 raised to minus 2, and D is equal to 1.35 centimeter is equal to 1.35 into 10 raised to minus 2 meter. To find electric current, from formula F divided by L is equal to mu 0 I1 into I2 divided by 2 pi into D. Calculation from formula 4.76 into 10 raised to minus 2 is equal to 4 pi into 10 raised to minus 7 into I divided by 2 into pi into 1.35 into 10 raised to minus 2, and therefore I square is equal to 4.76 into 10 raised to minus 2 into 1.35 into 10 raised to minus 2 divided by 2 into 10 raised to minus 7 is equal to 1.35 into 2.38 into 10 raised to minus 2 plus 7. I is equal to under root 1.35 into 2.38 into 10 raised to 3. There is equal to under root 13.5 into 2.38 into 10 is equal to anti-log into bracket 1 half log 30.5 plus log 2.38 into 10. Anti-log 1 half into bracket 1.1303 plus 0.3766 into 10 is equal to anti-log 0.7535 into 10 is equal to 5.669 into 10 divided by 56 into 69. Answer: the electric current is 5669 ampere. Question number 5. Explain magnetic force never does any work on moving charge. First, a magnetic force is given by Fm is equal to Q into bracket V bar into B bar. Bracket complete. Second, this makes a direction of magnetic force Fm bar perpendicular to direction of velocity of charge particle V bar. Say third, thus the magnetic force is termed perpendicular to displacement of charged particle. Fourth, according to properties of dot product, Fm dot V bar is equal to 0 for any magnetic field V bar. Hence, the magnetic force never does any work on moving charge. Question number 6. State the condition when the magnetic potential energy of magnetic dipole into bracket current carrying coil kept in uniform magnetic field be minimum and maximum. Answer: first, condition for the minimum magnetic potential energy in magnetic field: when the M bar and B bar are parallel to each other, magnetic potential energy of magnetic dipole is minimum. Mathematically, when theta is equal to 0, u is equal to minus m into b cos theta cos 0 degree is equal to minus m into b. Minimum potential energy M bar and B bar. Second, condition for the maximum magnetic potential energy: when M bar and B bar are anti-parallel to each other, magnetic potential energy of magnetic dipole is maximum. Mathematically, when theta is equal to 180 degree, u is equal to minus m b cos 180 is equal to mb. Maximum potential energy M bar is downward direction, B bar is upward direction. Question number 7. Derive an expression for the magnetic field product produced by current in a circular arc of wire. Answer: first, consider a circular arc of wire XY carrying a current I. Second, the circular arc XY sustained an angle theta at the center O of the circle with a radius R, of which the arc is a part as shown in figure below. A current carrying wire of shape of circular arc is diagram. Origin 0, then straight x and y is the angle dl bar, and direction I, r bar and db bar, and angle theta. Third, consider a length element L bar lying always perpendicular to R bar. Using Biot-Savart law, magnetic field produced at 0 is dB bar is equal to mu 0 divided by 4 pi into ideal bar into R bar divided by R cube. dB is equal to mu 0 divided by 4 pi into ideal into R sin 90 degree divided by R cube is equal to mu 0 divided by 4 pi into ideal divided by R square is first equation. Equation first gives the magnitude of the field of the direction of the field is given by the right hand thumb rule. Thus the direction of each of dB is into the plane of the paper. The total field at 0 is B is equal to integration dB is equal to mu 0 divided by 4 pi into I into bracket integration a to theta dl divided by r square is equal to mu 0 4 pi into I integration a to theta r d theta divided by r square is equal to mu 0 divided by 4 pi into I divided by r theta. Equation second, where the angle theta is in radian. येथे आपले सर्व शॉर्ट आन्सर फर्स्ट कंप्लीट झालेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद. Question number 9. What is a cyclotron? State the principle of working. A cyclotron is a cyclic magnetic resonance accelerator in which the alternating potential difference of few kilovolt is used to accelerate light positive ions such as a proton, deuteron, alpha particle, etc., but not an electron, to very high engineering of the energy of this order of few millivolt was developed by E.O. Lawrence and M.S. Livingstone in 1932. Principle. The cyclotron employs the principle of the synchronous acceleration to accelerate the charged particle, which is described the spiral path of the right angle of the constant magnetic field and make a multiple passes through a same alternating period whose the frequency is the same of the frequency revolution of the particles. Question number 10. What are the factors on which cyclotron frequencies depend? The cyclotron frequency depends upon first magnetic induction and second the specific charge into bracket the ratio charge per mass of the charged particle. इथे आपले शॉर्ट आन्सर पर संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.